Good morning to all of you students. Welcome to the physics class. In this session, we will study a most important chapter of class 11th, and this is unit and measurement. Student, in this chapter we will discuss deeply what are the units and how can we measure any physical quantity by the different methods. Including it, we will also discuss here error analysis. So it is an important chapter according to your syllabus. So start students. First of all, we will discuss here what is unit. As you know that in order to find any physical quantity, there should be two things are required. First is magnitude and second is unit. For example, if you want to find the volume of any container, then there should be two things are required. First, what is the magnitude of the container, and second thing is what is contained in the container. For example, if 2 liter water is contained by the container, then the unit of container is 2 liter. Clear? Okay students, there are two types of quantities: fundamental quantities and second thing is derived quantities. So first of all we will discuss here fundamental quantities and fundamental units. So fundamental quantities are those quantities which are not depend on any other quantities, and the units of these fundamental quantities are called fundamental units. Clear? Okay. Now students, we discuss here system of units. So there are four types of system of units in the physics. First is Cgs system. So in Cgs system, we will consider mass in a gram, length in a centimeter and time in a second. The same way in FPS system, we will consider mass in a pound, length in a foot and time in a second. In the same way, in MKS system, we will consider mass in a kilogram, length in a meter, and time in a second. Okay, students, in SI system, we generally use in the physics in the modern life for all physical quantities the SI system. So in SI system we also use mass in a kg, length in a meter and time is common in all the system and it is second. Clear? Okay students. So there is a table and you can see that there are 7 fundamental physical quantities and their units. So first is length and its unit is meter, symbol is m. Second is mass, its unit is kilogram and unit is kg. In the same way time, its unit is second and symbol is s. Fourth is electric current, unit is ampere, symbol is capital A. Fifth is thermodynamic temperature. Its unit is Kelvin and symbol is K. Next one is amount of substance. Unit is mole and symbol is mol. And seventh is luminous intensity and its unit is Candela, symbol is CD. Including it, there are two another quantities which are known as supplementary units. So there are two units which are plane angle and its unit is radian, and second is solid angle and its unit is steradian. Plane angle is generally used for the plane figures like triangles, square, rectangles, rhombus, etc. And solid angles are generally used for the 3D figures like sphere, cylinder, cone, etc. Clear? Okay students. Now we will discuss here only some terms like meter. So these are the terms which are only required for the definition purpose because their definitions are considered as a experimentally based, means these definitions are derived on the experimental base, on doing experiments. Clear? So 1 meter has been defined as the length of path traveled by the light in vacuum in 1 upon 2 double line, 792, 458 part of a second. Clear? Okay, students. This is the definition of meter, and it is the standard definition of 1 meter. Clear? Now, students, there are some units: kilometer, centimeter, millimeter, micron, nanometer, angstrom. These are the smaller and larger units of length. 1 femtometer is equal to 1 Fermi, and 1 Fermi is equal to 10 to the power minus 15. And the smallest units ever known is 1 barn, and its value is 10 to the power minus 28 meter square. So it is the smallest unit of length. Clear? Okay, student. Now, astronomical units. One astronomical unit is the average distance of the sun from the earth, and its value is 1. AU is equal to 1.496 into 10 to the power 11, approx 1.5 into 10 to the power 11 meter. So it is a larger unit of distance. The same way, light year. 1 light year is the distance traveled by the light in vacuum in 1 year, and its value is 3 into 10 to the power 8 into 365 into 24 into 60 into 60, and we get 1 light year is equal to 9.46 into 10 to the power 15, approx 10 to the power 16 meter. So it is higher units of distance. Parallelistic second or parsec, it is the largest unit of distance ever known. 1 parsec is the distance at which the average radius of the Earth's orbit around Sun would have sustained an angle of 1 second. Clear? So you have to learn only the value of 1 parsec. So its value is 3.1 into 10 to the power 16 meter, or you can also say that 1 parsec is equal to 3.26 light year. That means it is 3.26 times of 1 light year. Clear? Now, kilogram, it is a unit of mass, and 1 kilogram is defined as the mass of a platinum iridium cylinder kept in Paris, and 1 kilogram is the unit of mass. There are some higher units of kilogram and lower units of kilogram. So our 1 metric ton is equal to 10 to the power 3 kg, 1 quintal is equal to 10 to the power 2 kg, 1 gram 10 to the power minus 3, and 1 milligram is 10 to the power minus 6 kg. Clear? Okay. Second, now we will discuss here some units of second like millisecond, microsecond, nanosecond, and picosecond. These are the smaller unit of second. 1 sheik, it is also unit of second, and its value is 10 to the power minus 8 second. Okay, student. Now, student, we discuss here ampere. Ampere is a unit of current, and 1 ampere is defined as the current which, when maintained in two parallel and straight conductor of infinite length and negligible cross section area placed in a vacuum at a distance of 1 meter apart. So it would be produce a force which is equal to 2.2 into 10 to the power minus 7 Newton per meter length between the conductor. Okay, students. The same way, 1 Kelvin. Kelvin is the unit of temperature, and 1 Kelvin is 1 upon 273.16 part of the thermodynamic temperature of the triplet of the triple point of water. Clear? So these are the some basic definitions. Now, student, we will discuss here 1 mole. So student, 1 mole 1 mole is defined as the amount of substance which contain as many elements entire as there are atoms in 0.012 gram kg of carbon 12. Clear? Candela. Now next is candela. 1 candela is the luminous intensity in the perpendicular direction of the surface of 1 upon 600, double triple zero meter square of the black body at the temperature of the freezing platinum under a pressure of 101.325 Newton per meter square. Now we discuss here supplementary units. So first is radian. It is the unit of plane angle, and 1 radian is the angle subtended at the center of a circle by an arc equal in length to the radius of a circle. Clear? Now, angle is equal to arc length upon radius, and 1 radian is approximately equal to 57.3 degree. Now, steradian. 1 steradian is the solid angle subtended at the center of a sphere by the area of the surface of the sphere, which is equal to the square of the radius of sphere. Clear? So these are the basic definitions of fundamental physical quantities, and you have to learn only the values. Definition is not as much as important. Clear? Okay, student, we will discuss here drive units. So first of all, what is drive unit? Drive units are those units which are derived with the help of fundamental quantities, and they are depend on the fundamental quantities. There are number of drive units like volume, physical quantities like volume, density, velocity, acceleration, force, work, pressure, impulse. So these are the examples of drive physical quantities. Clear? Okay, students. Now, student, we will discuss here measurement of length. So there are number of methods by which we can measure the length or distance of any object from any other object. So we will discuss here only the name of that method and only formula, because this is also not most important topic. So there are methods. First is a reflection or echo method. So with the help of this method, we can find the distance of any object with the help of echo formation. And in this method, we use a formula v is equal to 2s upon t. So from this formula, we can also find the value of s. Clear? Okay, students. Now the second method is radar method. So first of all, I want to tell you what is the full form of radar. Radar, it is a radio detection and ranging. This is the full form of radar, and with the help of radar, we can also find the distance of any object with the help of radio waves. And the formula is s equals to ct upon 2, where c is the velocity of light and s is the distance covered by radio waves. Clear? Okay, students. Next one is laser method. So what is laser method? So first of all, I want to tell you the full form of laser. Light amplification. You can see that light amplification by stimulated emission of radiation. So it is important, so you have to learn the full form of laser. And here we use a highly monochromatic and unidirectional beam of light. With the help of this light, we can find the distance of any object. So this is also important a method. And here the formula is s equals to ct upon 2. Clear? Okay. Here in laser method, we use the laser beam of light in air. Next one is sonar method. Sonar. So sonar means sound navigation and ranging. With the help of this method, we can also find the distance or the depth of any object which is placed under water, such as sea rocks and submarines, by using ultrasonic waves. And these waves have a larger speed, like 1400 kilometer approx. Clear? Okay, student. There are some also other methods by which we can find the distance, like measurement of size of astronomical object. We can also find the size of any astronomical bodies like any star, sun, earth, moon. So these are the astronomical bodies by whose size we can also find with the help of this method. So here we use two formula. First is theta is equal to d upon s, and second one is t is equal to s into theta, where d is the diameter and theta is the angle subtended by an object, which is shown in the figure. You can see in the figure theta is the angle subtended by the arc of that object on the earth system. Clear? Next one is parallax method. This is also a most important method, and with the help of this method we can also find the size of any object from the earth surface. So you can see in the figure there is a orbit of earth, and from the orbit of earth we can find the distance and the size of any astronomical body like star, moon, etc., by making an angle sustained on the surface of that object. Here we use formula phi is equal to arc AB upon radius S. So we can say that phi is equal to SB upon S. This is the required formula. Clear? Okay, students. Now, student, so student, in this method in this video we discuss what is measurement of physical quantities, what are the fundamental quantities, what are the type quantities, how can we relate fundamental quantities with type quantities, and there are some method by which we can find the distance, size, mass of any objects. Okay, students, and we will discuss the second part of this video in the next lecture, and we will continue from the above lecture, above methods. So students, do as well as possible and learn the whole chapter very carefully. Thank you very much.